finding this microphone a bit awkward, but I'll start with it and we'll see where we go. So, look, thanks everyone for coming along. It's great to have the opportunity. So let me just give you a little bit of background about myself and the context of what I was going to tell you, a bit of a story about where we are and where I got to. So I'm retired. I was a CIO of Energex and Ergon as part of Spark Solutions, which was a joint venture between Energex and Ergon at the time. The two companies are now merged into Energy Queensland, so I got the golden handshake and out the door. So, but my other hat is as orienteering, which is an adventure racing sport. Kids got into it, running with Map and Compass. And so as I approached retirement, I thought I really wanted to get back to hands-on, having a bit of a play with the technology as it evolved for a long time, from the time I went to university to now. And so I've ended up with this app called MapRun, and I was going to tell you the story of MapRun. But I'd suggest this is a bit of a common career path where you get interested in a topic like motor cars. So you become a mechanic because you think the job's going to be tinkering with cars all day, but you end up very quickly in the office with the paperwork and you're not touching the cars anymore. And that's what happened to me sort of in engineering IT, and a lot of technical career paths end up in that sort of thing. So always interested to get back to hands-on, and the opportunity came along. So I wanted to get hands-on. So now I'm enjoying what I think has been enabled largely by the uniformity of Flutter data across a fairly wide ecosystem, which I think otherwise I probably would have said that's just a bit too broad to achieve things. So I have an app called MapRun, but of course, as you know, with apps, it's not just the thing on the mobile phone. There's a whole lot of other bits that need to go to give you a whole solution. So it's sitting there with about 11,000 users per month at its peak time. I'm not sort of counting installs, because a lot of people install apps and they sit on your phone or whatever. This is 11,000 times that people have gone out and done like a 5K run with the app on their phone. It's across 45 countries and 10 languages. So it's not going to make me $1 million, but it does cover its costs. There's a lot of apps there that just don't get take up, and I'm I suppose reasonably proud that it has got some sort of take up in its niche. So what I was going to do in a presentation is tell you a bit of a story that said, what is this adventure racing thing? What happened in the early days when I wanted to try out this idea of using a mobile app to support adventure racing? Then I flipped into Flutter, which was, I think, a critical change. And then we've ended up with Flutter app, web and server. I want to then just walk you through quickly so you know what happens in an adventure race with the app. I want to talk just quickly about some of the benefits of where that has been for me anyway, but some of the challenges along the way. And in the process, I would branch off into a bit of a comparison in my mind against Swift UI, because I've dabbled in that a little bit too. The internationalization is of interest, I think, and you can't have a talk on Flutter, can you, without state management, I think. So, and then where I'm going to next, and questions, comments and suggestions. But it's a fairly small group, so feel free if you do want to raise a point or raise a question in the context, certainly do. And I wouldn't mind just understanding from the audience, like, what's the level of experience and expertise in Flutter Dart? So can I have a show of hands? How many people would say, they're working in Flutter Dart, they've got an app or apps? So expertise, all right. So I hope you're not too bored. I hope you can see something in what I've done and help me out in the end, help give me some suggestions. What about others who, a knowledge, a working knowledge of Flutter Dart? Yep, okay, and then Flutter Dart as a name for the rest of us. Okay, righto. Managers, yeah, okay. All right, so just a very quick introduction to adventure racing or orienteering. So people run with a map and a compass, and the idea is it's a running to navigate to various control points, which are typically marked by these orange and white flags. And at that control point, you have a specialized looking map that's got the sort of an international standard for adventure racing or orienteering mapping, so people know the standard symbols for various features on the map, you know, creeks and gullies and whatever roads, and then you have a series of markers on the map that show you where you're going to go to. Now, some courses, there are line course, so you need to navigate in sequence through to a particular path, and others are a scatter event where you go to as many locations on the map as you can within a fixed time. So typically what's at a control point or a checkpoint is the flag and one of these electronic timing devices where you carry what looks a bit like a memory stick type thing, but it's a proximity RFID type technology. When you get to that location, you dunk this thing into the little hole in the top of that device. It records the control ID to know that you can validate that you've been to the right locations and the time, whatever. So that's what the sport is. The concept was, can't we take a smartphone app and make the organisation of these events easier and make it more flexible for the runner, for the user? And the core idea was to use GPS-based location tracking and then the registration of the punching of a control, you know, the registration that you're at that location just by proximity calculations to a latitude and longitude in GPS. Because one of the big things, particularly for small club events, is the effort for somebody to go out and put out the markers around for a course is a big effort. And if you've only got, say, 30 people coming and running in the event, somebody going and spending an hour and a half going and putting those controls out, and then another hour and a half later going and getting them back. And you can't leave them out in the field because these things here tend to get souvenired by, you know, bushwalkers, or if you do an urban event, you know, you might want to run around South Bank here in Brisbane. You know, people get curious and pick them up and take them home. Whereas if you've got a GPS-based course, the idea was not to put any markers out there. It's an armchair job to set the course, put the coordinates into an event set up in an app, and then track the runner and time them and validate that they've gone to the right controls, or score how many controls they've been to. So look, I'm not here about really being really sophisticated about Dart and Flutter, and so there's greater experience in the room than I have. This was about keep it simple, stupid, the KISS principle, and try and just get an outcome for the two interests I had, you know, dabbling in the technology, but being part of orienteering as such. So you'll probably see better ways to do things as I show you what I've done, and you might get a giggle along the way, but certainly come up to me afterwards and point me in the right direction if you see something. Right. I've got a clicker here, haven't I? Am I going backwards there or forward? Okay, here we go. Sorry, look at this, competence. Okay, so what happened was, you know, back about 6-7 years, Google had an app for Android called MyTracks. I don't know if anyone remembers. It was a reasonably good demonstration of the capability of the Google Maps API for Android. And so they put out this app that allowed you to record, you can see here, this is the recording of the number of runs or walks or whatever people have done, recording of tracks, and it would show your track. That blue line, which doesn't show too well on the screen perhaps, is the recording of the track. So it had the basic capabilities that I was thinking of for orienteering or for adventure racing. It just didn't have the timing and the registration of you visiting a particular location, but it was an awfully good start. So, and it was all open source because they were trying to demo their capability. So what we did, or what I did, was layer the navigation logic on top of the MyTracks app. And we ended up with a way of recording the locations you needed to visit, detecting the proximity in real time as you ran along to any of those control locations. And because we wanted that specialist map, we had to overlay a orienteering type map over the top of the Google map. Which I thought initially might have got Google offside because I was using their whole framework, but I didn't want to really show their map. But anyway, it never came to anything. So this turned out to be quite a good foundation, but it was quite complex because I think they wanted to show every twist and turn you could have in Java for Android at the time. And so, for example, we're good. We're getting a bit of background music. So for example, the track recording service was a completely separate process to the app itself. So you ended up with inter-process communication going on in Android, and you know, it was more complex for a beginner in Java for Android than I would have wanted. I don't know. I never really enjoyed the Android activity lifecycle thing about having to work out when someone's flipped the phone on the side, I've got to redo the whole thing or something or other. The screen layout, of course, is all in XML, which is separate from the code and all that sort of stuff. And the SQLite database was a good idea. So, can you read that? I was just trying to show you some of the complexity. So you've got good old Java, which is, I think, quite a readable language. But this thing here is, you know, talking about unbinding services and connecting services. All this stuff here is about determining the status of the service, and you know, not my favorite way of doing things, but you know, everything is an r.string something or other, that if you really wanted to know what that is, you've got to search off in the XML file to find out what the text actually is saying. So anyway, and then my friend, the Android lifecycle, which when I get further down the track, when I've gone to Flutter, I've forgotten about that thing completely, and I'm very happy that I've been able to forget about that thing completely. All right, so what happened was that sort of proved the concept, because it wasn't clear that with the GPS devices in phones that they were quality enough or good enough and fast enough that if you've got a runner running through one of those locations, that you would be able to reliably detect and confirm that they visited that location. So it was about the accuracy of both the placement of your latitude and longitude, and also the variability in the signal from the GPS, because most of these devices probably there so you knew where you were in the car, and they weren't really about precision in off-road type situation. Also, was it fast enough? You're typically getting a location every second, and you've got to think, if this is an orienteering, or say it's you can orienteer on foot or on bike or on skis, if you whiz through a control and you've got a point coming in every second, are you sure you're going to be able to pick up the fact that the person's been there? But it comes down to, ultimately, I'll jump ahead, but the way we did it was to have a tolerance of, say, 15 meters around each control, and you're really determining whether you're within 15 meters. But I generally say if you've got a whole batch of people running down exactly the straight line in open country, the breadth of the GPS tracks will be 7 meters either side. So you've got like a 15 meter, 14 meter variability just from the GPS device in the phone anyway. And then the person setting the course probably hasn't put the control in exactly the right spot. Anyway, so was it accurate enough? Was it fast enough? And was it stable? Because it's a bit of a harsh environment. You've got a runner who's just hot and sweaty, and they've got to either carry the phone or tuck the phone into their belt around their waist or in their pocket. And the thing I always feared was just that letting down somebody who's gone out for a run. They get halfway through the run, they get to the end and find that the thing didn't actually record the whole thing, and they're disappointed, and they'll just throw the app out because, hey, it wasn't reliable enough. Anyway, we could prove generally that those matters were okay, and so we built out an Android app. We also needed a results system on the end, because you run the thing, and so run and you want to upload results. So we found there is a results system for orienteering that came from a guy in Finland who obviously writes in Finnish, and he wrote in Perl. So the combination of people know Perl. There's a line of Perl there for you if you want to see. It's been called isn't it the write-only language? It's unreadable, so you can write it, but you can never read back what you've written. But that there concatenates all the lines of the input, reverses. It's a Roach 13 encryption algorithm where it replaces the A to Z, the first half of the alphabet and the second half of the alphabet, and et cetera, et cetera. But so we ended up with a really Why did you write it in Perl? Well, I mean, Perl and PHP were probably the two environments where they on platforms. So even on my Mac, it still comes with a Perl interpreter, doesn't it? Every Linux box has got Perl on it. Yeah, but why? So Perl came in, I think, more as a string manipulation type tool that was something more capable than Bash. But anyway, and it's still around. Anyway, we ended up getting some interest from our engineering clubs, got a bit of funding, got a freelancer through Odesk or Upwork, or whatever it is now, in Egypt, who was an ex-IBM who'd done a lot of Java, and he helped get some things going, and then we got some real events running. And we ended up with then a results system that showed, a list of names, the places people had been to, you could display their track, the times, the distances, and all that sort of stuff. So all of that was pretty much the stuff that I inherited. What we had to do was adapt it so that you could get results coming in progressively as people finished, rather than it's classically in an orienteering event, you have an upload device for that little memory stick, and at the end of the event, all that gets aggregated into a set of results, and then you put it to the results system, whereas this we needed to do more iteratively. Anyway, so we got some interest, but then it was Android only and half the world's on iOS, and clubs really said, I love the idea, but unless you can do it in iOS as well, it's just not viable. So I didn't have the equivalent of the MyTracks app for iOS, because obviously Google were Android centric, and so I couldn't just pick up and do the same as we'd done on Android. So I did the Odesk type thing and got a guy or an agency in India to say, I've got this, give me the same in iOS. And I was sort of devastated when I got the thing back. Like, first of all, it's like 80% of the job, and all the bits you got to fix and all that sort of thing. But the logic and the structure of the app was completely different I was originally imagining naively that I'd get almost a class by class, function by function, variant of Java across to Objective-C. But of course, and it turned out to be for the best. They just simplified the heck out of this thing and built it as how you would build an Objective-C app around the same database structure that we had, and producing the same user interface largely. And so ultimately, when I've taken the step beyond this, it's this version that we've really taken forward. Anyway, ultimately a good thing. But I don't know, I thought I'd just show a bit of code. Who knows Objective-C? Who loves Objective-C? For me, all the NS stuff, the next step stuff that was left over from Steve Jobs's operation in Next. Why do they have? I don't know why they have to have NS in front of everything, but and then all of this stuff, which was quite complex, I think, for a relatively naive developer. Non-atomic and strong, and my properties, and then the non. It's rather than a dot. You can't say class dot. Act or method or whatever. So it's all a bit back to front. And the whole world of delegates. I mean, in other contexts, I just hadn't run across the concept, but even now, Apple are still, I think, fairly keen on the sort of a delegate model. So anyway, we ended up ultimately with a Java app and an Objective-C app. We've got a website in Weebly that could give people instructions and tell them where to download the app and all that sort of thing. We've got a results system in Perl, and we had to have an admin console to allow people to publish an event to the server so that the app could go and get the coordinates of that event and the map for that event down from the server. So all of that sort of fitted together with Perl. We've got a group of people who were the representatives of each club who had permissions to go and publish events to the server. And I got some AWS Linux stuff in the background and some Apache, and away we went. So we've got a version 1 of a solution which is sort of holistic enough that clubs could say, instead of setting up an event in the old style, I've got a method complete enough that I can set up an event for next week's run. I can get somebody to set it up, people can come with either Android or iOS. They can run in it. They'll see their results. The admin console, they can tweak the results and do a few things like that. And so you've got a sort of an end-to-end viable package of what you'd need as a club to run an event. Okay, but it was still fairly basic in that, and there were lots of new ideas, lots of features to be added. Obviously, we had scoring schemes and different variants of orienteering. So, but every time somebody wanted like a new variant of scoring, what do they have to do? You have to do it in Java on Android and Objective-C on iOS, and then of course on the web-facing, the web front, you have to change, and the back-end server stuff. So I'm doing it either 3 or 4 times, and that became quite soul-destroying because I don't know, you get excited the first time you're creating a new feature in an app and you test it once, but if you've got to test it in at least 2 different main contexts. And then the other thing was we're on a slippery slope because Java was being replaced by Kotlin and Objective-C was being replaced by Swift, and well, HTML, CSS, and Perl weren't going anywhere, but I just didn't enjoy them. So that's where we were. And then, so Flutter and Dart were emerging, and I had a look at things like that Cordova phone gap thing, which was really a shell around JavaScript, but I wasn't really a JavaScript developer, and I was a bit worried about a sort of a shell around an algorithm for something like driving the GPS or receiving signals from your GPS in your phone, so it didn't seem like a good thing. There was Xamarin, which is the Microsoft-aligned one, but I wasn't a .NET developer, and React Native, but I wasn't really coming from being a web dev, trying to be an app developer. So Flutter Dart really did look good to me because it was right at once, and in that writing it, you got the app logic and the UI in the, and I didn't really enjoy the Android thing where I had the code over here and the screens over there, and the promise that was coming for web, and server was already there for server, but was coming for web. And the approach they'd taken looked like it was good for performance. So we were actually compiling on iOS. So you're going to get very similar code. You're running in the Java, the JVM on Android. So it was going to be fine. And then you've got the web and server. I thought the language Dart is nice and clean, certainly compared with Perl and Objective-C. So the first step, I just jumped in after I'd retired and I thought I'll just grab that iOS, the Objective-C one, and I just rewrote it in Flutter, and that turned out to be great to have that bit of real-world experience with the first version of the app, so you knew, what features were important. You could drop a few things maybe, and it worked pretty well. Pretty easy to do, and the whole process worked well. I found the tools to be modern and capable. The debugging, I don't know, it might be just me, but whenever I'm in Objective-C, I can never get down to which actual line number caused the bug. But in Dart, you actually get line number and you get, character number on the line. So the stack tracing stuff's good, and there was good enough community support, like Stack Overflow. But now, I just ask AI, and AI is knowledgeable about Dart and Flutter very well. So I think he's going to do something on that. So the most significant barriers, but at the time, there seemed to be a turf war going on about state management. There were whole lots of different views, and at the time, I was tearing my hair out thinking, why didn't they just build one of these things into the product and then just kill off the whole war? But anyway, greater minds than mine thought about that. But I decided, can I just keep it simple? And I fundamentally just tried to use the features that are in the base language, like obviously the set state and those sort of bits and pieces that come with the base language. I think I'll talk about that a little bit further. But the other thing was, by developing in Flutter, you do bring, it's quite a long build chain down through Android and through iOS. So anything that's a bit challenging, it's going to come up in your project. So I got this background geolocation package because, back to that point about my fear was I didn't want this thing to stop working halfway through. And at the time, there were lots of apps that would record your location, but as soon as the app lost focus, as soon as it became a background app, the operating system stopped it, using the GPS. And so you don't want that to happen because the people are running along, the screen's gone blank, but you do want it to keep recording the location. So the best package was this one from a guy who just specializes in that, and he does it across all of the different development systems, including Flutter. But in that, he's got a whole build chain. They've got to have compatibility down through Gradle versions and this, that, and the other. And on the iOS side, you've got to, you've got your pods and all that sort of thing. Yes.
If the mobile phone loses connectivity, that impacted, or does it still run the GPS separately that then buffers and then uploads data?
Yeah. So one of the design principles was to say, because phone coverage isn't what you'd like it to be, and these people are going, out into bits of bush, we only needed the internet to pull the event down from the server, which they could do from home, and to upload the result to. So while you're out there running, everything it needs is on the phone, and the GPS doesn't need internet. The GPS signal continues. You'll find, we tried to buy a whole lot of cheap phones that we said, oh, we won't put a SIM card in them, but it does have that assisted GPS thing, and it doesn't work as well if it doesn't have network connectivity. But the phones have improved. The phones have improved a lot. Yes. Yes. Yeah. There's a satellite receiver which operates wherever you are. It doesn't. Yeah. Yes. You can keep tracking where you are without the internet, and you might see on Google Maps, like it'll know where you are, but it can't render the map because it can't get data. Yes.
Is this local or is it local?
So is what the server which has the events. So I want to run at New Farm Park. There's an event this tomorrow. I find that by going into the app, I select event, it goes to the server and gets the event file from the server. You go off and run in the event, and then you push a result back to the server. And the server is the one that's feeding that result system. The server's AWS Sydney. Yeah, cloud. All right, I'm going to keep punching on here. How are we going? 27 minutes in. All right, so we did the app into Flutter, and that seemed to be working well. So Flutter Web was in its infancy, but that old console and old scoring system were pretty clunky. So I tried Angular Dart. Anyone been down that path, Angular? I found it to be real, and I didn't end up building a version of the console in Angular Dart, but I found it counterintuitive, complex, and it still had HTML in the middle of it. I think I've got an example of it here. You've still got your HTML part here, and then you've got these directives and providers and your codes down here with all this ng prefix. On a net, you do something to get tasks, and when somebody taps a button, you do an ng submit, that sort of stuff. And it didn't get me away from HTML, which is what I was trying to do. Let me just go back. So I was trying to sidestep HTML and CSS. I like the idea that Flutter just grabbed the whole screen as a game console would, and painted its own view. So then on the server end, there was a package called Aqueduct, which I think I go to, which has now become Conduit. And there's Google have come out with Shelf, and there's Dart Frog and Drift and a few other things. But the fundamental function of that is to act as a HTTP server. So it sits on the server, it listens on a particular port, and it gets the HTTP requests for, say, give me that event, and it's got parameters and all that sort of thing. So it does the handling and routing of HTTP requests, and then it does that ORM thing, which is I've got a Postgres database in the background, and if you're writing in an object-oriented language, you don't have to do the remapping between the objects and the database tables, because that's all done for you. And it turned out to be scalable and just runs on the server. So this is what the server code then started to look like. So you've got a main program here, which it's just introducing a bit of complexity here. So it's about futures with async and await. So you've got asynchronous programming. It runs an application taking its configuration from a file which has got all the database configuration in there, and this is going to serve and listen on port 8888. So you send a HTTP request to 8888, it's going to come in here, it's going to hit this thing called a router, which looks for if the URL is /auth token, it'll send it off to this class here, auth controller, and if it's user ID, it'll send it off to. So you write a function or a class to handle each of the sort of API requests you're going to have. But the thing is, you're writing all of that in Dart, the same as you're writing the other end of it. So what I would often do would be I'd be sitting there writing the client end of that, and I'd be writing the back end of it at the same time. And a lot of the logic and the code is very similar. So we ended up with, I decided not to put all my eggs in one basket, and we ended up writing 3 Dart apps on the service with 3 different ports, 8888, 8887, 8886, very imaginative of me. And they just served, various sets of the calls. So one of them deals mainly with the calls from the app, one from the admin console, and one from like the result system. So you got 3 apps that just sit there. They're running on, they are still running on Amazon, AWS EC2 Linux, hosted out of Sydney, but servicing all the world. And they've been rock stable. They've been running for years, and good stuff.
What's the cost of those per month? Just out of interest.
So the whole server configuration back end I've got.
Yeah, just the next 62 specifically.
Well, when you get a bill from Amazon, so you've got the EC2 part, I've got storage, I've got some S3, I've got a load balancer that fits in front of the 3. I've got 3 servers. I've got a Pro, the backup, and a development machine. So, but roughly I'm paying $500 a month. And it does the job. All right, so then just back to the web. So it was great that it was all just widgets, the same, no HTML, CSS, unless you want to put some in there, because you can integrate HTML, CSS into the, you have to be adaptive to screen sizes. Browser compatibility turned out to be pretty good until you try to go to the WASM, the WebAssembly thing, which is still coming. So it is for building web apps, not for websites, if I can make that distinction, because you really just want to use it for where you want to process, logic, not where you want to just present static content. But you can provide links direct into various functions via these routes. So if I wanted to get into the event system to a particular result, you can pass a parameter in on the URL, and so it works like it was HTML pages if you want to go that way. So just on the web devs thing, I just did it in Android Studio, the same as I was doing for mobile. You don't get the hot reload, but it's a pretty quick recompile. The debugging in Chrome on Mac, it just renders into a Chrome window, so you can do it all locally. When you're finished, you just do a Flutter build web, and you decide which renderer you're going to use, Canvas Kit, or in future the WebAssembly one. So I've got a front end then, which is it's a static web app. You have to host it somewhere, so I just ended up with Firebase, and so you just deploy it to Firebase with a command like Firebase deploy for hosting for this particular app, and in 10 seconds, the new version of the app is in Firebase. And that's great. It's simple to roll out. It's even got a rollback. If you stuff it up, you can pull back to the previous push you did. And unlike the mobile app, as soon as you push it, everybody's got the same version. Whereas, when you roll out versions of mobile apps, I'm still dealing with, really old versions. We have got a capability where an organizer can set a minimum version, but they rarely do. I don't know, quick walkthrough, maybe. How are we going for time, Enki? No, yeah, I'll just keep going and just we can come back and have a look at the end if you like. So the web app for the administrator effectively is just a classic looking progressive web app thing with you know, the menu drawer on the left hand side, set of functions, you log in, and to set up. So this is the life cycle then of an event. So somebody goes in and they put all of this data. I don't expect you to read it, but you have to upload some files for the map, the file for the course, you have to set some date ranges, you give it a name, all that sort of stuff. You've got a whole lot of settings. You've got 60 settings or so that you can set for the characteristics of the event. Do you want to be able to see where you are? Do you want to hide the track? Do you want to let people start anywhere on the course? Do you want to, you know, only run, you know, whatever? So they go and then they add that event. It then sits up on the server that the event, the app can come and grab. Then you've got the MapRun app. So what happens typically at a club event, so this is organised by like orienteering clubs, you'll go to an advertised event, they'll give you a paper map because it's still, even though we do show the map and the locations on the screen, people still want a paper map because it gives you the context. So we tend to print a paper map that has a QR code. So we can do a deep link into the app so that it pulls up the right event and takes you into that right event. So you can be confident that the paper map you've got corresponds with the same event that you're about to run in, and we put a 4-digit PIN or a lock code on it so that people have to pay their money before they can go and run in it. So then so at the moment you can run Android, iPhone, we've got Apple Watch and Garmin Watch, and serious runners prefer the watch than having to carry their phone, but obviously we couldn't do those latter two in Flutter. I'd love to be able to, but we didn't. Sorry, and so this is really what the app looks like. You know, put your user profile in, find events near me or a select event from a list. You can have a look at all the options and settings, go to start, or show results from previous events. So when you're out there in the run, what happens is you can look at the map on the phone if you want to, but most people don't. They just tend to tuck the phone away and it beeps and vibrates when they get to the control marker. And if they did look at the screen, it's got the control turns green. And then we do have a live tracking option. So that's another web app we've built that allows, so in that case, it does need the internet. What happens is we just send locations every, say, 20 seconds to a Google Firestore. And it's great because it does all that queuing. Like if the phone's offline for a while, it'll do the catch up. I don't have to worry about all that logic and whatever. Anyway, that's another app. And then what happens at the finish is people see the track that they ran and they sit down and do the post-mortem as to, you know, why, you know, someone beat you or where you made a mistake or all that sort of thing. So we've ended up then with Flutter on Android and iOS. We've ended up with a Weebly website, and we've got Flutter with Firebase hosting for the results and the Android and the admin, and we've got Dart on the back end and AWS Linux. We won't do that. So just sort of to sell the praises or sing the praises of Flutter Dart, like I think it's a great logical, plain language. You know, it's easy to come to it from C or Java, I'd suggest. I think the async stuff, the isolates, the memory management all work, and what you see is what you get. The web, I think, works really well. I don't have any problem with it. It does avoid the activity lifecycle nightmare I used to hate with Java Android, or I think you've still got it with Kotlin. The approach to the screen layout of putting the layout, you know, the widgets thing within the code, that makes sense to me, and I think it's been adopted. You know, it's what Swift with UI, I would suggest, has taken a similar sort of page out of this book. But it is a bit more natural than Swift UI, and I'll just draw a little comparison there. The bottom line for me, like as a single guy trying to keep all this thing together, is not having to switch contexts and think about, oh, gee, what's it like? You know, well, how do I do that in whatever? Because I just think how do I sort, you know, a list in something or other? And if I'm switching context between Objective-C or JavaScript or whatever, you know, I'm forever having to go back to my AI chatbot or something or other. And so that's really been the savior for me. And a lot of the code, like the ability to just pick up blocks of code and move them either from, you know, the front end of the web to the back end on the server, or from the app to the whatever. So like if I put in a new scoring scheme, the logic for calculating the score, I do need to have that on the server as well as in the app, because I want to present it directly. So, you know, I don't have to write it twice, you don't have to debug it twice. So I think it makes a big difference in the whole working solution, at least for me, to be able to have such a tight environment. So in Flutter, just like one of my go-tos typically is a stateful widget. And a lot of my screens, you seem to get that notion that, okay, somebody wants to bring up the list of events. So what happens is you've got to do a bit of work. You've got to call out to the server, get the list of events, and then present them on the screen. So it's always do a bit of work and then pop the UI. So that future builder built-in widget, which this is an example of. So you've got a future builder. What happens is when this thing first fires up, it goes to a init state, and I call a setup data, which you can go off and do all the asynchronous work of calling whatever. And the future builder is looking after the UI. It puts whatever you want there, puts a circular progress indicator up on the screen. And when it comes back and returns either an error state, but hopefully not, but returns back that it's completed, then your full UI just appears. And so a lot of my componentry is that future builder type construct. In comparison with Swift UI, because I had to delve into Swift UI to do the Apple Watch one, like it's a very similar sort of thing. You've got a view with a stack of what would otherwise be called widgets. These are a series of buttons. But instead of having that sort of the UI as like part of the overall class, the UI is sort of front and center. And to do your logic, you've got to do like what do they call them? Who knows? A modifier, I think, on the view to say, before you appear, do all this stuff. So in here would be, you know, load the saved event and whatever. It just seems back to front to me, but then everyone, you know, gets used to different things. So Swift UI to me is very much focused on the UI, and the app logic hangs around that, whereas I prefer the logic of saying, what am I doing? And then I present something on the UI. And their state management's a bit different with their, you know, state, this, that, and the other. They like widgets, and the on appear is not really on appear. The other thing I think was really good in Flutter is if you want in context help, like so here we are, we've got a text widget, and if I, you know, do an F1 or whatever I do on that, I get all of this rich content that says maybe there's something here that gives me a clue. If I want to change the color, I can see color, selection color. And so all of the properties of the class are there, pretty much obvious to what you do. What I struggled with in Swift UI was, so here I've got an overlay with a text with a title, and you might see underneath there foreground style white just sneaking above the box there. If I do a help on that, I get told that text is a struct. That's good, and it's got a init SS. That sort of doesn't help me at all. And then I go down here and I see the example is .font title. So there's something more going on there that doesn't. And then you get into this font stuff, and you end up with these sort of signatures with the, you know, anonymous parameter or whatever that thing is. And if you go even further, so if I look at the button, I think, okay, I'm starting to understand this. I've got a button with two parameters, an action that sounds, and that's a, you know, anonymous function to take action, and a label. But then they give you the example down here, which is button action, close bracket. So where did the label go? The label has become a trailing closure. But But that signature there doesn't align in my mind with that signature, because they've gone for, if the last parameter within a function call, I think it is, or within a class, is a closure, you can hang it off the back as a trailing closure, and they say that makes the code more readable, but for a beginner it doesn't. Okay, so internationalization I thought was really going to be a big problem, but it turned out to be quite easy. I don't know whether you guys have done much with this, but I18N was the package I took, and so just wherever I put text that I wanted to have in different languages, they extended the string class with an I18N call, and you can run a job across your source code. It'll extract all of those into files that then you upload into, I don't know whether you know the Crowd-In website, which is used for lots of different applications, but you upload your files to there, and it gives you tools to automatically translate to various languages, or you get your friends in Germany or wherever. And they're usually if you've got users who want to use the app, they love contributing by translating it to their own language. And so you just find a keen person in Finland, Germany, Hungary, and whatever, and they will. And so, anyway, the beauty, and then you end up with these files just in your locales folder, which you never go into, but that's what's generated by Crowd-In. But the beauty for me is there's no keys in the text. You know, like right back in the early part of the presentation, we had the good old branch off to the XML text strings, but you can search the code and say, where's that button for, go to start? And that go to start is actually in the source code, but it uses that as the key to then give you the translations. And if you miss any, all that happens, it doesn't all fall over, it just gives you the English rendition of that. So it's pretty fail-safe. So the challenges I've had, it tends to break every time something gets upgraded. iOS versions, Xcode versions, Android build, Gradle, whatever. But I think I don't think it's any worse than anything else, but it's just a bit frustrating that you can spend a bit of time getting it going again when something changes. The other thing I think is there's been a fair bit of evolution in Flutter Dart, and some of the stuff that you did in a certain way initially has now changed to a different way of doing things. And so it has just simple things like color schemes and styles, but also the XML parsing package changed their idea from XML parse to XML.document.parse. You think, well, yeah, okay, and then the web view thing changed, and the Java interoperability changed, but that's evolution, I guess. And the big one, but was the non-null safety to null safety, which needed a whole sort of re-engineering of your code, and material 2 to material 3 has been a bit of a change. Some functionality has been a bit slow to arrive in the Dart ecosystem, I'd suggest, but generally that's not been a problem. And the big thing is there's no Flutter for my 2 watch types, the Garmin, which has to be written in Monkey C. I have a guy in overseas who does that for me, and Apple Watches, but I did the Swift UI one myself. But again, you pick up the WWDC or whatever they call it, their Worldwide Developer Conference, and they had a demo of a workout app, and you can pick that up and then sort of adapt it. Development, I just used Android Studio. I normally use the iOS simulator as the target for the app, because you can get to the files directly. Hankey's giving me the wrap up. Things I haven't done well, I haven't done automated testing very well. I tried Espresso in the early days on Android, CI/CD. I haven't done a real slick UI design, and I haven't really done anything with dependency injection and sort of holistic state management by any of the I'm not a disciple of any of the particular methodologies. But for state management, what I have used is a bit of a provider, but generally they're just inherent things. But for the type of app that I was using, I didn't ever want, if somebody accidentally closed the app halfway through an event, or the battery went flat or whatever, that they couldn't resume. So effectively I'd need to keep writing everything to non-volatile memory anyway. So the state is being written to shared preferences or to the database. And so that is my sort of global data, and I keep referring to that. Language seems to work okay. The components are pretty much what we've had before now with the web, and we've got integration with Garmin and Strava and all those sorts of things, mail merges and whatever. What's coming next? I'm attracted to the WebAssembly thing because I think just deploying things as web apps, I reckon, has been really good, but it doesn't quite work in all the browsers as yet. The AWS backend, I'm on old Linux, I've got to bring it up to date. And then to use these sort of apps in schools, they've got this new Safer Technology for Schools thing, which has a whole set of reasonably high level benchmarks, or not benchmarks, standards to which you need to comply so that you're not causing harm to kids. So that's a threshold I need to decide whether I'm going to try and take the app to that. But mainly the main thing is to just keep having happy users who get out there of all ages and try and have a run whenever they can. And that's my story about Flutter.